This is a demo of the Akasia Infrastructure Modeler. To access the tool, you would go to sas.akasiacloud.com and create a new account. Once you've created the account, you would log in. And then you're presented with two of our products, AIM, which is the Akasia Infrastructure Modeler, and it's used by enterprises and service providers for lift and shift cloud modeling. And ACM, or the Akasia Cloud Modeler, and this is used for brand new cloud deployments. So let's click on AIM. With AIM, the first step you would do is discover your on-prem environment, and you would do that by clicking on Manage Source Data. Here you can see a number of environments that we've already discovered. In order to discover your environment, what you would do is download our remote collector. Our remote collector is a small Java executable. You would download it and run it in your local environment that you're wanting to discover. And it essentially connects into your vCenter or SCOM or your management software. And once it connects into your management software, it pulls all the data that we need to be able to do our modeling. For VMware environments, this is the information that it pulls from vCenter, and it puts it into CSV files that you can read. You would then upload these CSV files into our SaaS application. Another option is RV tools. A lot of VMware environments have RV tools running. This is an open source software, and the RV tools essentially do some monitoring. We can take the output of an RV tools monitoring exercise and you can upload those as well. If your environment is non-VMware, such as Hyper-V or KVM, then we have discovery tools that also discover those environments. And once again, we'd create these CSV files that you would upload. For physical environments, we would give you scripts that you would use to connect into the CMDB or to connect directly to the servers and pull the host information as well as the utilization information, and you would upload that information as well. So once you've uploaded these CSV files, then you would see the data set show up as one of these. For today's demo, I'm going to look at this particular data set. So in this data set, we have 108 hosts. This is the CPU, memory, disk information about the hardware that's supporting these hosts. These hosts are running 1675 virtual machines, of which so many are on, so many are off. Here is very important information: network usage and I/O. These are hidden costs that are often responsible for surprise costs in the cloud, and with AIM you get to see these costs very clearly to be able to see that on-prem this is what your utilization is, and these become chargeable items in the cloud. You also have the on-prem resource summary. So these are your total host costs, your VM costs, and here's your spare capacity. In this chart, we show you the cloud costs for your particular environment. So if you were to take all of your VMs and migrate them to the cloud platform, this is what the costs would be. You can also swap out the regions. So you have various regions listed here, and you can swap them out, and so maybe go EU West and see the costs associated for the different regions. Here we go. And then finally, you get to see what your spare capacity is. This is idle capacity that you've already paid for on-prem, but you don't want to be carrying over idle capacity to the cloud where you pay for every resource that you've provisioned. So after taking a look at the overall summary of your environment, what you would likely do is you'll create a modeling group. So with Akasia, we present to you some of the groups that we've pre-discovered. And so these are convenient starting points for you to do your modeling. You can also individually pick your virtual machines and create a custom group if you wanted to. Let me show you the predefined modeling groups that we've already created. So this is by hosts. So you can simply pick any of the hosts and add them as a new group. You could also pick an operating system version. So all the VMs running a particular OS version can be chosen as a new group, or subnets. So you could simply pick any of these subnets and add them as a modeling group. Tags. Tags are a very convenient way. A lot of environments use tags to monitor, or rather organize which VMs are supporting what applications. And we are able to read the tags, and so you can simply pick the tags that you want and add them as a new virtual machine. Applications as well, and then data centers and powered state. So here, for the purpose of the demo, I'm going to pick an application. So let me see. I'm going to pick this application. The next step would be to proceed to cloud planning. Okay. So we're going to select all of our VMs and then add to modeling group. All right, here we go. So here we have 175 virtual machines that are supporting that application. This is your resource detail about the machines, and here's your on-prem costing detail. Right here, what you'll see is the cost variables across all the different clouds. And then you can flip down these charts and look at where you actually save by moving to the cloud. You can also look at the difference between the compute costs across the different clouds, as well as storage costs, network costs, I/O, and as-is costs. So interesting thing to note is as-is is essentially looking at the cost for all of the virtual machines that includes all the excess idle capacity. And so, for example, for Amazon On Demand, it would be something like $99,000. And if you were to right size, then it would be 45,000. So it's almost 50% savings you would get by right sizing. So as you scroll lower, what you get to see are all the different cards for the various clouds, which show you the cost breakdown. So network, I/O, storage, compute, total cost, and of course we're looking at EU Central, which is Paris here. And you see the cards for VMware Cloud and Azure, IBM Cloud, as well as Google and Oracle. For the purposes of this demo, what we're going to do is pick Amazon reserved instance. And we are going to take a look at the list of equivalent Amazon templates for our on-prem virtual machines. So in this example, what you get to see are two lists. This is for as is, or the compute equivalent, and this is for right-sized, as in only looking at resources that have been utilized. And you can see what the costs breakdown here is, and in particular what you'll find interesting are these right-sized savings. So you'll see that there's quite a lot of savings from right-sizing. And if you're curious as to how we came up with this, you can take a look at the configuration tab here. And here what you get to see is detail on what was allocated to the virtual machines versus what was actually used. So in this instance, there's a lot of headroom here in this virtual machine where 4 vCPUs were allocated, but only 2 are being utilized. And 378 gigs of storage was allocated, but 108 gigs is being utilized. 30 gigs of memory were allocated, but only 4 are being used. So there's quite a lot of excess capacity here, which leads you to quite a lot of savings. Another interesting feature here is that even though we've recommended a C5 dot large, you can override a recommendation with another template. So instead of a C5 large, you could go for a C4 X large, and then you would see the prices change here. If you're wondering how we come up with a right sizing, we look at 1 year's worth of utilization data, and in particular, we keep track of the peak usage. So we don't just look at average usage, but we actually look at peak usage, and then we add on a little bit of extra headroom so that with a right size template, you would have sufficient headroom there in case your application is spiky. Now, in this instance, we've done the mapping for all over 100 virtual machines here. So you have the full list of equivalent as well as right-sized templates for the cloud. The next step would be to add additional cloud services. And here, what you would do is you would add any other Amazon resources that you want to add. So you could add something like serverless compute. So you would just enter the details here. Add product. And so it goes ahead and adds Lambda. In this case, it looks like our costs are 0, which is good. You could add storage. So you could add additional block storage if you liked. So we've added block storage. You could add networking. So perhaps, let's see, bandwidth consumption for egress and ingress. So we could put that in. And we've gotten the price for that. Security. So you can go ahead and add DDoS. We've added that. That's quite a large amount sum there. And so on. And you can also add databases. So things like in-memory database, so you could add that. Here we go. So in addition, any of these others, and then a whole bunch of others. Essentially, all of the The entire price book for Amazon is available here for you to be able to do your modeling. And so it gives you a pretty flexible set of steps to do your full modeling here. The next step would be to add other costs. So in this instance, your one-time cost would be things like migration or anything else. And so for migration, let's assume we're going to do, say, and then the monthly other costs would be recurring costs such as network, admin costs, and so on. So we can say this is it. And then we proceed to Cloud Report. And here we are. So we picked 175 virtual machines that are supporting our application. Here are the on-prem costs. And here's your monthly summary comparison. So your on-prem costs are so much. Your one-time migration cost is $60,000. Amazon reserved instance is $44,000. Amazon reserved instance as is this much. On demand right size is this much, and on demand as is 107,000 plus. If you have cloud discounts, you can add that here. So maybe you're getting a 20% discount. So you can apply that, and there you go. And as you scroll lower, you get to see more and more details. This is the exact breakdown of how Amazon would invoice you. So we are showing that to you. And then here are your VM configurations. And then as you scroll lower, you get to the bill of materials, which shows you the compute equivalent as well as the right-sized and so on. This is your full bill of materials list, and here are all the advanced services that you selected, the other cloud costs, the one-time costs, and here's your total summary. And you can save this project plan in your account and come back to it later. You can also export this, and this exports as a PDF as well as a spreadsheet, and then you can edit it further if you like as a spreadsheet. So this is the demo of the Akasia Infrastructure Modeler. Very quickly, if you wanted to edit the source costs, you could do that right here. Our application uploads some default figures for hardware, software, maintenance, taxes, etc. But you are able to edit them. And if you're looking at the categories, these are all your pretty standard categories for CapEx and OpEx tracking. And this is typically what your enterprise would already have. And so you can simply upload this, the data for your environment over here, or you can simply use what Akasia has taken as default just to get started. You can edit costs by doing this, and you could click this, say 24 months, and then maybe click that and make it much more expensive, and you'll see that the prices change here. So my monthly price has changed. I can apply changes, and those changes are successfully saved. So this is a demo of the Akasia Infrastructure Modeler, which essentially discovers the on-prem environment, applies dollar figures to the cost on-prem, allows you to create groups, and then do the cost modeling for the different groups. So that's it.